What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at 4.2, which is about translation, so how to use rigid motions to translate figures on the coordinate plane, describe the effects of those translations, and then determine the translation vector. We've got some vocabulary terms, so I'm going to type this in first, then we'll draw some pictures. So translation definition is when all points of a figure move the same distance, which we'll call magnitude, in the same direction as described in the translation vector. And then a translation vector is when it describes the direction and magnitude of the translation. So I've got some pictures for us. Let's go ahead and look at those to see what they look like. So translation could be, here we have like triangle ABC, and this will be done on a coordinate plane, so I'm just going to estimate to see how it moved. But you can see that triangle ABC moved to triangle A prime, B prime, C prime, and it went to the right and up. So things we want to consider, maybe this translation vector was right 7 and then up 1. So we're using this with these two little brackets here. This first number is always going to represent the x. That is going to be a left or right movement. A left movement is negative and a right movement is positive. And then the second number is representing the y movement. That would be up/down. Up would be positive and down would be negative. So those are the things that we're going to see. A translation can also be written as a rule. So for this rule, we would say x comma y can be translated to x plus 7. So again, that's our x value, a little bit more specific with this one. And then y plus 1. We're just going up 1. So this would be a rule, and then this would be the vector. So go ahead and take time to copy this down, and when you're ready to go on, unpause the video and go ahead and click play so we can see how to do some examples. So example 1 says, determine the translation from ABC to JKL and write the translation vector. So first, what I would do is I would find two corresponding points, like point B corresponds to point K, and I'm going to first decide my translation would be an X, which is left or right movement, and then my Y. So it looks like I'm going to go to the right, 1, 2, 3, 4, 5. So I'd be seeing X plus 5, and then I went up 2 points. That'd be y plus 2. You can also describe this using words like the figure is translated 5 units to the right and 2 units up, but this rule is a little bit easier to write. And then the translation vector is when I just use those numbers by themselves. So that'd be the vector 5, 2. Next up, we have a different one. Let's see if you can try this one on your own. So go ahead and pause the video here. Try this one on your own, and when you're ready to check it, go ahead and click play. So example 2 is very similar to the first one. Determine the translation from ABC to JKL and write the translation vector. Again, I start with a corresponding point like A going to J, and I'm going to go left first, 1, 2, 3, 4. So that would be my first rule. X would be minus 4. And then I go down 1, 2, 3, so that'd be y minus 3. So my vector would be -4, -3. Flipping over to the back, I have a few examples here. So let's go ahead and start with example 3. Here's where you're going to plot the original points first and then show the translation. So let's go ahead and plot those points first. I have 2, 4 for letter X, 6, 0 for Y, and then 7, 2 for Z. And I'm going to go ahead and draw those dots together, making that figure. Then it says my translation is going to be showing X minus 4 and Y plus 2. There's a few ways we can do this. The first method I'm going to do is just counting. So I'm going to actually go to the letter X, and I'm going to count left 4, 1, 2, 3, 4, and up to 1, 2. So X prime would end up here, and that's going to be point -2, 6. So let's go ahead and continue counting for the rest of these. Letter Y, left 4, 1, 2, 3, 4, up to 1, 2. So Y prime is going to end up here at 2, 2. and then z prime left 4, 1, 2, 3, 4, up 1, 2. So this one's kind of overlapped just a little bit from the previous one. Z is at 3, 4, and then I would just connect those points. Notice it's the same triangle, it's just slid over to the left and up. Okay, if you want to try example 4 on your own, go ahead and pause the video here, try it, and when you're done, click play. I'm also going to show you another way that you can find your new points and then just graph those. All right, so the first thing we want to do is graph our points that are currently of x, y, z. So x is -3, 2, y is 5, 4, and z is 8, 1. So go ahead and label all those. And then, as best you can, making the straight lines to make your triangle, okay? Now, this translation vector says -3, 4, so that's when I'm going to take my x value and subtract 3, and my y value and add 4. So what I'm going to do first is apply that rule to every single one of these. So x minus 3, y plus 4, x minus 3, y plus 4, x minus 3, y plus 4. So this is another way to do it. That's what I would be considering the algebraic method of we're just adding and subtracting x's and y's. So my new x value, -3 minus 3 would be -6, and 2 plus 4 would be +6. My y values, 5 minus 3 would be 2, and 4 plus 4 would give me 8. And then my z prime, 8 minus 3 would be 5, 1 plus 4 would be 5. So now when I plot these points, it should still show my translation of left 3 and up 4. Here's left 6, up 6 for x prime. Some people like this method better just because they don't have to sit there and count every single time. 5, 4 is actually going to end up, 2, 8 is going to end up way up here. And then z prime is 5, 5, so just above that old y point, and then connecting our dots, we now have our translated triangle, 3 units to the left and 4 units up. Okay, that's going to be all for our translation lesson today. Thanks so much for tuning in. Hopefully this gives you a good idea about how to write rules and vectors and apply translations, and we'll tune in next time about rotations. Have a great day. Bye.